Analysis, Chapter 9, Section 7. We're going to be doing products and quotients of complex numbers. I'm your host, Dr. D. Okay, time to get started here. So we have two complex numbers and we'd like to multiply them. Now, for your entire lives, up till this point, in order to multiply those two numbers, you'd have to FOIL them. And then you'd end up with two middle terms you'd have to add up, and then you'd end up with an I squared, square root of 6, and that'd be just nasty. So what we're going to do is we're going to convert each of these rectangular complex numbers into polar form, and then it will be much easier to multiply them. Watch the magic. Okay, so 1 plus 3i, or I'm sorry, 1 plus I squared of 3. That's 1 right and square root of 3 up. So clearly you recognize this is a 30, 60, 90 right triangle, and so the angle is pi over 3. And the magnitude is 2. So we can rewrite 1 plus I squared of 3 as 2 cis pi over 3. And now square root of 2 minus square root of 2i. So that means we go right square root of 2 and down square root of 2. So you also recognize this as a 45, 45, 90, so that makes the hypotenuse 1 because, wait a minute, 2 plus 2 is 4, huh? So that makes it 2. All right, we'll be that way. Yeah. Okay, let's make sure I got this one right. Yeah, that is right. Okay, so, yeah, that's right. If I had made this 1, 1, that would have been square root of 2. Okay, so this is square root of 2, square root of 2. This has to be 2. And we know that the angle is 45 degrees in the fourth quadrant, which makes it either negative pi over 4 or 7 pi over 4. So, just for our purposes here, let's call this negative pi over 4. It doesn't really matter. So this becomes 2 cis negative pi over 4. Okay, now when we multiply these two complex numbers, all we do is multiply the magnitudes and add the angles. So this just becomes 2 plus 2 is 4, and pi over 3 minus pi over 4 is 4 pi over 12 minus 3 pi over 12, which is 1 pi over 12. That's it, game over. Now, if I want this back in rectangular form, which often I do, then all I have to do is say this is 4 cosine pi over 12. So 4 cosine pi over 12 is 0.9659, so we'll make that 0.97. And sine pi over 12, 4 sine pi over 12, oops, I didn't multiply that by 9, or by 4, huh? Okay, let's do that again. Pi over 12, cosine of that, yeah, so we've got to multiply it by 4, if you want to be picky about it. So this becomes 3.86 in the x direction. And in the y direction, we just take our pi over 12, take the sine of it, and multiply that by 4. So get 1.04. Oops. 1.04 I. Okay, so notice we started with a real plus imaginary times real plus imaginary, and we convert them into polar form. Now, polar form, all we do is add the magnitudes, multiply the magnitudes and add the angles. So then if we want to, we can convert it back to rectangular form. Okay, so let's take a look at our basic formulas for this section then. Yeah, we'll just get rid of this. So for multiplication, we've got R1 cis theta sub 1 times R2 cis theta sub 2 equals R1 R2 cis theta sub 1 plus theta sub 2. Okay, so multiplication says you multiply your two radii and then you add your two angles. And division says R1 cis theta sub 1 divided by R2 cis theta sub 2 equals R1 over R2 cis theta 1 minus theta 2. Okay, so basically for the multiplication, we're multiplying the radii, adding the angles. For the division, we're dividing the radii and subtracting the angles. That's it. So notice how much easier it is to multiply two numbers in polar form. Now, what about addition and subtraction? Well, they're much easier to accomplish in rectangular form. So, one of the courses I had when I was a chemical engineering major was in circuits, which was really torment to make a chemical engineer do electrical engineering. But when you're sizing a transformer, you've got inductance and capacitance. Now, capacitance is voltage that's stored. So it's in a complex number, and then inductance is current that's stored. It's in a complex number. Now, when you want to add those two complex numbers, you want them in rectangular form. When you want to multiply the two complex numbers, you want them in polar form. So, in order to do the process where you're distributing and then combining, you ended up having to convert from polar to rectangular back to polar again, and it was a major blast. So that's what we're doing right here. Okay, so let's take a few examples here. Okay, now remember, the book doesn't use the notation cis. Every single time the book is going to show it, they're going to go cosine plus I sine. Like I said yesterday, way too much writing. Okay, so let's take a look at, we want the product of 3 cis 7 pi over 6 and 2 cis 2 pi over 3. So 3 cis 7 pi over 6 times 2 cis rats. 2 cis 2 pi over 3. We're going to multiply those. So all we do is we say 3 times 2 is 6. 7 pi over 6 plus 2 pi over 3. We need common denominators, of course. So that's going to be 7 pi over 6 and 4 pi over 6. And so 7 plus 4 is 11 pi over 6. Now our last step, we want to turn it back into rectangular form. So this is going to be 6 cosine 11 pi over 6 plus 6I sine 11 pi over 6. Now, what's 11 pi over 6? It's pi over 6 short of 2 pi. So we've got negative 1, 2, and positive square root of 3. So the cosine is going to be square root of 3 over 2. So it becomes 6 times square root of 3 over 2 plus 6 times the sine, which is negative 1/2 I. And so this becomes 3 square root of 3 minus 3I. That's it, game over. Okay, now let's try some division. So we're going to go 12 cis pi over 4 divided by 4 cis 3 pi over 2. Okay. Okay, so we've got 12 divided by 4, which is 3, cis 3 pi over 4 minus 3 pi over 2, which is 3 pi over 4 minus 6 pi over 4, which is negative 3 pi over 4. Yeah, 3 minus 6 is negative 3. Okay, that's happy. Okay, so now what we want to do is we want to see if we can simplify that angle before we change it. So that's just going to be 3 cis. Instead of 3 pi over 4 clockwise, it's going to end up being 8 pi over 4 is all the way around. So it's going to be 5 pi over 4 counterclockwise. Remember, 5 plus 3 is 8 pi over 4, which is a full circle. So 3 cis 5 pi over 4. Now, what is that in rectangular form? That would be cosine 5 pi over 4. Remember, here's your 5 pi over 4 right here. And so this is negative 1, and square root of 2. So the cosine is negative square root of 2 over 2. So it's negative 3 square root of 2 over 2 minus 3 square root of 2 over 2 I. Or negative 3 square root of 2, oops, rats, blew a tire there. Negative 3 square root of 2 over 2 minus 3/2 I square root of 2. That's a little more formal way of displaying the answer. And of course your book puts it, something has gone awry. 5 power 4. What happened here? Oh, I know what happened. I didn't copy the problem down the way it was in the book. So we just did our own example problem. So it's all happy now. Okay, so we're going to try one more, and that's going to be the electricity that I was telling you about. So this is a really simple example of what I was telling you about with inductance and capacitance. So we have a circuit that has impedance 2 minus 6J ohms. So impedance, well, okay, we've got Ohm's law, which is V equals IR. Voltage equals current times resistance, or impedance. You spell it with an A? Let's see. Yes, I spelled it right. Okay, so voltage equals current times impedance. So they tell us that the impedance is 2 minus 6J ohms and the voltage is 120 volts. So we've got 120 equals I times 2 minus 6J. Now the J is basically an imaginary root. So let's see. Yeah, I got to make sure we actually copied this right. So here we are. Now what I want is the current, or the amperage, and that's going to be 120 divided by 2 minus 6J. Now, I actually think if you want to end up with rectangular coordinates in the end, it's actually easier in this one to just go multiplied by the conjugate. So we're going to end up with 120 times 2, which is 240, plus 6 times 120, which is 720, J, all over A plus B times A minus B, which is A squared minus B squared, which is actually going to be plus 36. So 240 over 40 is 60, and 720 over 40 is 18. So that would be your final 6 plus 18J would be your final answer. So the current, as doing a full sentence, the current is 60 plus 18J amps. Amperes. But we just say amps. Bam, that's it. Game over. Now, let me show you, rather than multiplying by the conjugate, let me show you the method that we're focusing on this section, and that is changing it to polar and then doing the division. So do that over. So we've got 120 over 2 minus 6j. Okay, so this is 120 there we are, 120 cis 0 over, now 2 minus 6 means 2, negative 6. So that's not a special right triangle, so we basically just have to do our Pythagorean theorem. So 4 and 36 is 40. Cis, and what's the angle here? It's going to be inverse tangent of negative 6 over 2. So inverse tangent of negative 3 is negative 1.249. Okay, now, it really becomes easy doing the division now, because 120 divided by 40 is 3 cis. Now 0 minus a negative 1.249 is just 1.249. See, that's why I didn't bother changing the negative 1.249 into a positive. Like, I could have added 2 pi to that to clean it up, but the thing is, I didn't want to clean it up. It was just an intermediate step. So now I have 3 cis 1.249. Now you already have that number in your calculator. So what I would suggest is you just change the sign of it in your calculator, then hit enter twice. So it puts the number in there twice so you can use it 2 times in a row. Now, if I want the cosine of that, all I do is hit cosine and multiply by 3. And that gives me 0.948. And then I hit sine of that angle and multiply that by 3. And I get 2.85. So something has gone awry here, because it should have been the same thing as what we had before. What the heck did I do wrong? Okay, 120 cis 0 divided by that's obnoxious. You guys didn't even say anything. It's not 40, it's square root of 40. That really bugs me. Okay, cut, take 2. We're starting over. So now we've got 120 divided by square root of 40. Which equals 120 divided by 2 square root of 10, which is 60 over square root of 10. Yeah, we'll just clean that up a little. So we've got 60 square root of 10 over 10. Which equals 6 square root of 10. Okay. So I've got 6 square root of 10 cis 1.249. All right, I have a feeling this is going to work this time. So what I do is, once again, I need to go inverse tangent of negative 6 over 2. So inverse tangent of negative 3 is negative 1.249. And I change the sign and I enter it twice. And so now I'm going to take the cosine of that and I'm going to multiply it by 6 squared root of 10. And I get 6. Then I take the sine of the angle and multiply that by 6 squared root of 10. And I get 18. There. That's much nicer. So, that's basically all there is to this. Notice, all we're doing is changing the rectangular into polar. And remember, when it's pure real, then it's just 126 0. When it's a combination, then you do Pythagorean theorem. Don't forget your square root, or you could be badly mistaken. And then you've got the inverse tangent of negative 6 over 2. And like I said, just leave that in your calculator. And we didn't actually even need to clean this up because we're going to rectangular coordinates. So we could have just left 120 over square root of 40 in our calculator. And then multiply that by the cosine of the angle and sine of the angle. That's it. Have fun with these.